Hi, Azuni and Naisha. So let's start the class. So we were doing kinetics and we discussed about 1 second. Rate laws. So one of the rate law which we did was like rate is equal to k times concentration of A raised to power x, and x is the order of the reaction. The another we did the integrated rate laws like natural logarithm of concentration of A is minus kT. K is the rate constant, T is the time, and then the natural logarithm of initial concentration. Like this is for the first order kinetics. We did this also. So these are the rate laws, and we did this also, that rate is defined as the change in concentration over time. This one. We did this also. So till now we have understood the meaning of the rate and how to calculate the order of the reaction, how to identify the order of the reaction. Order word is also clear to us. Today we are going to do another method for determining the rate law. All these methods are experimental. You need experimental data. Rate laws are always experimental. In fact, this one, the one which we are going to do today, that is also experimental, right? But here we are going to determine the different steps which are involved in the reaction. So I'm going to explain the meaning of elementary steps and energy profile. I'll discuss few other things like what is a catalyst. All these things we are going to do today. Okay, children, I just want to inform you that today's class is only for 1 hour. I'm somewhere else and I have to visit a temple today. Maybe you heard about it. It's there in uh, Puri, Odisha. I'm here in Puri, Odisha, and there is a very famous temple, Jagannath Puri. So the Pandit told us to come exactly at this time. I requested him to shift it, but he said no, otherwise the crowd will be too much and you will not get a good view of the God. So I said, okay, fine. So I'll cancel the class after 1 hour. I'll end the class after 1 hour and I'll give you extra 30 minutes in the next class. That is on your Thursday, right? On Thursday, extra 30 minutes. I hope that's okay with you. Yeah, yeah, Anil. Yeah, you know it. We visited it. It's a golden beach, something like that. Yeah, it's really nice, very nice. I really enjoyed there. And it's one of the, I think, very neat. And we went to Goa also, some other places, but I found this one very peaceful and very neat. Okay, so we have less time, so let's start. So first, I will tell you the meaning of the elementary steps. This is very simple concept. Try to understand it. Like for example, if there is a reaction A to D, like this reaction is taking place in multiple steps. Like first A is converted to B, then B is converted to C, and then C is converted to D, like this, multiple steps. Then these steps are called as elementary steps. A to B, you cannot further simplify it. It is the simplest step and it is elementary step. So A to B is the elementary step. A to D is overall reaction. Overall reaction. A to B is elementary step, B to C another elementary step, C to D another elementary steps. You add all these elementary steps, step 1, step 2, step 3, you add all of them, then you will get overall reaction A to D. The rate law is from the elementary step. For the overall also, we work out the from elementary steps only. So what is the rate law for an elementary step? It's going to be the same as the reaction. Means you're looking at this reaction. What's the reactant here? A. How many reactant molecules are involved? Only one. So the rate law for step 1 is, let's say I'm just changing this just to make a different type of reactions. So what's the rate law for first step? It is K times concentration of A raised to power 1. Only one molecule is involved. So here I'm going to determine the rate law from the coefficients of the reactants which are involved in elementary steps. There is a big difference in the rate law from elementary steps and for overall reaction. For overall reaction, I cannot do that. I cannot determine the rate law from the reactants and their coefficients. I need that experimental data to determine the order. But for elementary steps, you can. Now, what's the rate law for the second one? Rate equals to K times concentration of B raised to power 2. See, B is 2 here. That's why. What's the rate law for the third elementary step, Azuni? Can you type it? Rate law for the third. Yes, K times concentration of C raised to power 3. This is for the third, right? So rate law from the elementary steps is from the reactants and the order is the coefficient. Here the order is the molecularity of the reaction. In elementary steps, order is also called as molecularity. Molecularity means how many molecules are involved. So what's the order here? For first step, what's the order? This one. 1. 1 means molecularity is also 1. You can see that only one molecule is involved. Only one molecule is involved for the product formation. So this is unimolecular reaction. If order is 1, we'll call it as unimolecular. Only one molecule is involved, unimolecular. Now what's the order here for the step 2? Yes, Azuni, what's the order? 2. So we are going to call it as, if it is 2, we call it as bimolecular. Bimolecular. Bimolecular means order is 2. When it is 3, we call it as trimolecular. 4, tetramolecular, like this. So what's the molecularity from the elementary step? It's the number of molecules which are involved here, okay, as for the formation of that product in the elementary step. Elementary steps, overall chemistry, overall reaction chemistry, element steps chemistry is different. Elementary steps are, you cannot further subdivide them. You cannot take out any more steps out of it. And the rate law for elementary step is from the reactant and the coefficient of that reactant in that balanced equation, the way we have written here. Azuni, Naisha, any questions? Ariba? Ariba, you joined late. So try to understand. Ask your questions if something is not clear. So ready for my questions then? Okay. Write the rate law for this elementary step. Rate law. Rate equals to K times, K is the rate constant, concentration of CH3 and C raised to power. What's the coefficient of this? 1. This method is valid only on elementary steps, not on overall reaction, children. I've seen that when I'm explaining this concept, students they take it that okay, whenever a reaction is given, you just take the coefficients of the balanced equation. No, it's only for the elementary steps. The simplest, which cannot be further more simplified. The ultimate step, right? Okay, what's the molecularity of this reaction? Molecularity. Molecularity is 1. Only one molecule is involved. Write the rate law for this. Rate equals to? Yes, unimolecular. Azuni, very good language. Unimolecular. What's the rate law for the second one? K, concentration of O3 times concentration of NO. Raised to power 1 here, 1 here. What's the molecularity of this reaction? Molecularity? Molecularity is? Yes, Anil? Here, in the second one, in the B part. Molecularity is 2. 1, 2. See, 2 molecules. It is bimolecular. Bimolecular. Molecularity is 2. Unimolecular. So we use these words, unimolecular, bimolecular, like this. Write the rate law for this. So I'm waiting for the answer. For the C and D, you have to do on your own. Write on the rate law for C. Rate equals to K times. K is the rate constant. Naisha, K is always the part of your rate law. So K times. Yes. Yes, yes, Anil, very good. Concentration of O3 raised to power 1. This is concentration, square brackets. So, what's the molecularity of this reaction? Is unimolecular. The reaction is unimolecular. Okay, let's do the last one. This one. Which one is going to split? Which one you are talking about? This one? Yeah. So, there's only one reactant for this, one reactant. So that's the rate law for step C. Yeah, yeah, good. Okay, D part. Let's do the D part. What's the rate law for the D part? I think Anil has already written K times concentration of O3 raised to power 1 times concentration of O raised to power 1. So what's the molecularity of this reaction? Bimolecular. So the molecularity and the order is same for elementary step. Okay, molecularity and order is same for elementary step, right? So elementary steps, the rate law is determined from the reactant from and their coefficient. Their coefficient is the molecularity as well as the order only for the elementary step, right? Like for example, now I'm going to show you the energy profile. You have understood how to write down the rate law for elementary steps. Now let's see the energy profiles. So let's say A is giving you B, B is giving you C. Can you add these two reactions? These are elementary steps. A to B, elementary step. B to C, elementary step. Means the reaction is taking place in two steps, right? So can you write down the overall reaction? Overall means you are going to add step 1 and step 2. So Aditi, what's the overall reaction? This B and B cancelled. A to C. That's the overall reaction. A to C. This is overall. Right? Okay, now what's the rate law for the step 1? Elementary step. Step 1 is the elementary step. Rate law. Rate equals to K times this concentration of A. What's the rate law for the second step? Rate equals to K times concentration of C. B is, if you see here, B is formed. It is formed in step 1 and used up in step 2. So B is intermediate. What is an intermediate? Intermediate is formed in one of the elementary step, formed first. Formed. Intermediate is formed in one of the elementary step and then used up and used up in the next step. Intermediate is never the part of overall reaction. See here, intermediate is not here. Now how to make the energy profile? Look at this energy profile. This reactant is A. This product is the C. This one, C. Please understand the energy profile. A and this is C. And here is your intermediate. What is the intermediate in our example? B. Now when the reaction is going from A to B, this one, and when it is going from B to C, this one, two steps, A to B, B to C, these two, step 1, step 2, both the steps are visible on the energy profile. And here is the energy, right? So which one do you think is slow step? In which case the energy needed to cross this barrier, this is called as activation energy. The minimum amount of energy needed to start the reaction, this one. This is the energy needed to start the reaction. So in which case the energy needed is more, in step 1 or in step 2? Aditi, you are understanding? Aditi, you are there? Yeah, please ask your question. You joined quite late. Okay. So A to B, which one needs more energy? No. Check from here, Anil. Okay, I'm using a different color to make you understand. See, this is my A, the reactant A for the step 1. And this is the energy needed, total amount of energy needed, this one. And for the second one, this is the reactant B for the second step. B is the reactant. And the total amount of energy needed is this only. So in which case more energy is needed? In 1. More energy means fast reaction, slow reaction. More energy means fast or slow? Yes, children? Slow. So A to B is a slow reaction and B to C is a fast reaction. The rate determining step, the one which is going to determine the rate law, is the slow step. So remember this. What is the rate determining step? The rate law determining step from elementary steps is the slowest step, the step which is going very slowly. So A to B is the rate determining step. This is the one which is going to determine the rate law. Rate determining step means the rate law for this overall reaction. Important concept, children, very simple but very important. This was my overall reaction. If you remember this one. What's the rate law for this overall step, overall reaction? What's the rate law? The rate law is same as that of the rate determining step, which is this. So the rate law for this overall reaction is rate equals to K times concentration of A. From this one, the slow step. So in this slide, you have understood the meaning of energy profile, what is an intermediate, how to determine the rate law. Rate law is determined from the slow step. How to use this energy profile to identify the slow step. Children, are you getting it? Okay, I'm going to clear it. Let's say there is a reaction 2A giving you B, B giving you C, C giving you D. What's the overall reaction? Wait 1 second. A is giving you B, B is giving you C, C is giving you D, and A is here also. Are you talking about the previous reaction? Anil, I think I missed your question. What was the previous? A to B, B to C. This was the previous reaction, right? Yeah, Naisha is saying it was A to this one, right? Okay, children, I'm answering question asked by Anil because I missed it. Then this is A to C. That was the reaction, Anil. So rate law for the first step is K times concentration of A raised to power 1. Rate law for the second step is K times concentration of B raised to power 1. Now this is A, reactant A, first step. This is B, product of step 1. This is your C, B to C. So the energy profile for A to B, so this step you set slow. So this is the rate determining step, this one. So this rate law is the rate law for the overall reaction. Oh, okay. Thank you for correcting me, Anil. So children, sometime I'm talking, speaking, and trying to make you understand. So I may do error in writing. So you're most welcome to correct me because it's very important because some children are just totally dependent on recorded sessions. So please keep correcting me in case I'm doing some error in writing. Okay, now let's write on the rate law for A to B. K times concentration of A. Rate law for second elementary step. K is the rate constant. K times concentration of A times concentration of B. Rate equals to K times concentration of C. This one. These are the rate laws. Now I'm making the energy profile, children. Energy profile. This reaction has 3 steps. 1, 2, 3. Let's see the overall reaction. So if you look at the overall reaction, I think you already gave me 2A is giving us D. So what is B? B is formed and used up. C is formed and used up. What is it? Intermediate. B and C are intermediate. So I'm going to make the energy profile, Azuni. Check here. I'm starting with A. Here is the energy. Energy profiles are very important. And here is your course of the reaction. How the reaction is taking place. Course of the reaction or reaction progress, yes. They are very important for organic chemistry also later on. So reaction progress, how the reaction is taking place, right? Okay, now this is A and this is B, correct? B is formed and this is C and D. How many steps in this reaction? From the energy profile. So they will give you an energy profile. This is called as multi-step energy profiles. You look at the energy profile and then you identify the steps. So A to B, B to C, C to D, 3 steps. How many intermediates? So right now we are doing multi-steps energy profile. How many intermediates? 2 intermediates. Which step is the slowest step? Rate determining step. Rate determining step, the slowest step. Which one? Step 1. See the highest amount of energy. Very good, Azuni. Aditi. Step 1. So rate law of the step 1 is the rate law of the overall reaction. So what's the rate law for this one? Rate law for this one? Rate equals to K times concentration of A raised to power 1, not 2, 1 only, because this is the rate law. You are not going to determine rate law for the overall reaction from the coefficients. See the difference, Aditi? This is the rate law for elementary step, which is valid here. I'm not going to consider 2 here. So, what's the molecularity of this reaction? 1. What's the order of this reaction? 1. But if you look at the overall step, the molecularity appears to be 2. So, there's a difference here, right? So, rate laws for multi-step reactions are determined by the rate laws of the elementary steps. In the elementary steps, we pick up the step which is slowest. That is the step which is going to control the rate of the reaction, the slowest one. Like there is a race going on, that race in which they, what you call it, when they pass. What kind of race is that? When there are multiple players and one person is starting the race, then is passing the buck to the another person, something like that, and then they are running. Relay races, yes. If some race is going on, what is the focus of the one who are making the teams and all these things? They focus more on the runner who is slow, because he is the one who can make them win or lose the race. Because the fast runners, all the fast runners, they can make a difference of 1 second, 2 seconds, something like that. But the slow runner can make a big difference. If the slow runner of one team is really, really very slow, that team is definitely going to lose. If the slow runners of other teams are faster, means not very slow, that team will win. So slow step is the rate determining step here also. Whatever step is slow is finally going to control the rate of the reaction. So am I clear, children? Okay, now I'm giving you one energy profile. Energy profiles are very important. There are plenty of questions on my website also. Reactant, product. Tell me how many steps? How many steps? One, two, three, four, five. Very good. Very good. Anil, five. Check. Anil, five. Okay. Which step is the slowest step? Which step is the slowest step? C to D. What's the rate law for C to D? Rate law. Rate law for the C to D. K times, K is the rate constant, concentration of C, right? Yes. Okay, so rate law is this. So what's the rate law for the overall step? Reactant to product. Overall step is reactant to product. You add all of them, they all cancelled out. So what's the rate law? Rate equals to K times concentration of C. How many intermediates are there? How many intermediates? One, two, three, four. There are four intermediates. Naisha, right? You count them like this. So they are the one which are formed and used up, right? Four intermediates. Intermediate is something which can be trapped. It can be like you can observe them during the reaction. These are the intermediate, these valleys. Okay, let me show you again. This is the reactant. This is the intermediate. These are the valleys, right? They can be trapped. You can observe them that they are formed and used up. Experimentally, you can observe them. They are slightly stable, low energy. See, low energy. But what is this? What is this top of them? Any one of you? The top of them? Transition state. Transition state. Big thing. I will explain you in detail as it comes up more. Transition state. It is of highest energy. You can see that. They are of very high energy. Very high energy. And these transition states, we can write it like TS. This one is TS. This one is TS. How many transition states are there if you have five steps? You know, this reaction has five steps. So how many transition states? These are the questions. They give you energy profile. They will ask you how many intermediates, how many transition states? Four. One, two, three, four. No, five. Five steps, five transition states. Can you check? This is one, two, three, four, five. Every step has one transition state. Right, Aditi? A to B, reactant to B, one transition state. Ariba, you're not answering anything. Your name is not coming up. Ariba, you're there? Yeah, please keep answering. This is a very simple question. Okay, try to understand. Notes, children, I have made good notes about these. These are made by me on the website. So download them, take a printout, keep it next to you, keep checking what I have written in the notes. You have to be very proactive. for everything. Notes, quizzes. Now, hardly any time is left, 5 months only. Work hard. So, 5 transition states, right? And then these are the intermediates B, C, D, E. Transition states are the most unstable state. Transition states are the most unstable state. Why? Because they are the one with the highest energy, top of the hill, most unstable. Unstable means very high energy. They have high energies. They are the one which you cannot identify. You cannot like you cannot trap them. So during the reaction, transition states are never observed. We don't have any experimental proof for them. We don't have any experimental proof for transition states. So what are transition states? That I'll explain you. So transition states are formed and immediately they break down. You see, you reach on the top of the hill and then breaks down. Top of the hill, breaks down. Top of the hill, breaks down like this. Intermediates, they are lesser in energy, so they are slightly stable and you can trap them. So try to understand the difference between transition state and intermediates. Okay. We'll do more energy profile. So let's do this question. So how many elementary steps are here? 1, 2, 3, 4. Okay. So what's the rate law for every step? Children, you are answering this question. You answer this question and you are the winner of this particular concept. Rate law for the first step is K times concentration of O2. This K is different for different steps. Okay, concentration of O2. Second step, rate law is K times this. These Ks are not same. They are different. You can write K1, K2. Okay, if you want. Then this is N2O5 raised to power 2. This coefficient. These are elementary steps, right? The rate law for the third is K3 O raised to power 2 N2 raised to power 2, and the rate law for the fourth one is K4 NO raised to power 2 O raised to power 2, right? These are the rate laws. Elementary steps rate law. Which step is rate determining step? Identify the rate determining step. Which step? 1, 2, 3, 4. Step 2 is rate determining step. Okay, write the overall reaction. Overall reaction means you're going to add all these steps. So you have to check what all are the intermediates. Intermediates. This O2 cancelled by one of this. This is left as one only. So O2 is the intermediate. These two O cancelled. These two NO cancelled. These two O cancelled. Is there anything else cancelling out? Okay, so write down the overall reaction. Now what is left? Naisha, you're getting it? It's really fun. Giving you, oh, NO, N2O2, N2O2 cancelled. Yeah, thank you. So 2 times N2O5 is giving you 2NO2. Not 2, 4. These two added, 4NO2. That's how you have to work out your overall reaction, right? And what's the rate law for this overall reaction? Rate law. You cannot look at this equation and write on the rate law. You have to see the rate determining step, which you said step 2. So the rate law will be same as step 2, right? Is it okay? Now, what are the intermediates? O is intermediate. Oh, one O2 is also there. One second. On the product side, that's what you are saying? Yeah, I'm writing here. One O2 is left. Is this equation balanced now? Yes, it is balanced. Yes. Thank you, Naisha. So this is the overall step, and the intermediates are, you see, one of the O2 was also intermediate. O2, O, N2O2. These are intermediates. NO, these are intermediates. So everything is formed first, and then, oh, one of them, okay, children, intermediates are this. There are only three intermediates. O2 is not an intermediate. O2 is a catalyst here. Like for the intermediate, we said they are formed first. First, they are formed and used up. Used up. That's the intermediate. You check O is formed in the step 1, used up in your step 3, formed and used up, right? O is formed in step 2 also and used up in step 4. So they are intermediates. What about O2? Is it formed first? No, it is added. So what is a catalyst? It's added. It is added first. You're adding it and then used up. So O2 is added in step 1. You can see here, I'm adding O2 and then it is used up and then regenerated. So you can write down like this. A catalyst is added and regenerated, reformed. First added and then reformed. See the difference? Intermediate, formed first and then used up. Catalyst added first and then reformed. So O2 is added, it's reacted, it's used up, but then it is regenerated in another step. See here. So please write down these things because these are the most important question. They will give you multiple elementary steps and like this question, and they will ask you to identify intermediate, catalyst, overall reaction, rate determining step, like these very simple questions. And they may give you energy profile also, right? Let's see what is their next question. Okay, let's do this question and then we can do this part also. First, let's do this question. Ready for the question? This is the overall reaction. What is the correct rate law for the disappearance of N2O2? They're asking something else. So pay attention what they are asking. N2O2 is the reactant in step 1. Was in step 2, sorry. In step 2. What's the rate law for step 2? What's the rate law for step 2? Mm-hmm. Step 2 rate law is K times concentration of N2O2 times concentration of O2 raised to power 1 and 1. This coefficients are 1, 1. That's the rate law. And this rate you can say is the rate of disappearance of this N2O2. You can write it like this also. Minus delta N2O2 over delta T. You can write like this. This is the rate of disappearance of N2O2. And that's the rate law. So that is the question. They are not asking normally what is the slowest step, what is the intermediate. They're asking what is the rate law, what is the rate for the disappearance of N2O2. So you have to see that N2O2 is used only in step 2. So you write down the rate law for step 2. Steps are elementary steps, right? Now I'm asking more questions based on it. Can you identify the intermediates, and is there any catalyst also? Yes, identify. This is step 1, this is step 2, this is the overall reaction. Do we have intermediates? What are the intermediates here? Yes, N2O2, this one. That's it. Because intermediate is not the part of the overall reaction, and N2O2 is formed first. It is formed in step 1 and then used up in step 2. So it is formed first and used up, right? Okay, so intermediate is there. Do we have any catalyst? No, because rest all are the part of your overall reaction. Catalyst is also not the part of overall reaction, right? Okay, so catalyst, rest all are there. I can see NO here, O2 here, NO2 here. So there is no catalyst. Okay, now how many steps? 2 steps. How many intermediates? 1 intermediate. I'm making the energy profile. What is here? And what is here? And what is here? Mhm. This is the progress of the reaction, how the reaction is progressing, or the course of the reaction, or time, you can say. And here is energy, energy profile. What is here? Reactant. What is the reactant? 2NO plus O2. What is here? Yes, children? What is here? This, this one, which can be trapped, which you can identify. Mhm. Intermediate, yes, N2O2. Very good. And what is here? The product, 2NO2, the product. So energy profile. Which one is the slow step? This is step 1. This is step 2. Slow step is step 1. Why? Because the energy, see the energy hill. Hill is quite high. Takes time to reach on the top of the hill. So step 1 is the slowest step. So which one is the rate determining step? Rate determining step. Step 1. Step 1 is the rate determining step. So what's the rate law for this overall reaction? Rate law for the overall reaction will be determined by the rate determining step rate law. Rate determining step is step 1. The rate law for the step 1 is rate equals to, yes, yes, Aditi, very good. K times concentration of NO raised to power 2. So rate equals to K times concentration of NO raised to power 2. Right? So energy profiles, making of the energy profiles, identification of the intermediates, very important concept. Now I'm going to teach you another thing, which is called as steady state approximation. The name is very complicated. And don't worry about the name. Understand the concept. Here we are going to do some approximations, but we are not going to get involved in too much of mathematics of this particular concept. We have to understand in a very simple manner. Let's see how. Okay, can you see these two steps for this overall reaction? Can you determine the rate determining step here? What is the rate determining step? What is the rate determining step, children? Step 2. Let's write down the rate law for step 2. Rate law is K times concentration of Y times concentration of B. Am I right? What's the molecularity of this step? Not plus, Aditi, times. Concentration times. What's the molecularity of this? Rate law is the product of the concentration of the reactant raised to power some coefficient which is called as order. Molecularity is 2. Now look at this reaction. Naisha, pay attention here. Look at this reaction. In this reaction, do you have Y there? Y? Y is the intermediate. Am I right? Y is the intermediate. No. But if you remember, I gave you conditions for the rate law. The condition is rate law is always in terms of the reactants. You cannot have intermediate there. You're getting my point? You see, there is a when you are going to check my notes, there is a I think I have made notes about the rate laws, the conditions that rate laws are always determined experimentally. You have to perform experiment. These are also experiments. Rate law is always in terms of the reactants, never in terms of the product or intermediate or something else. So how come I can write this rate law? Because Y is not the reactant. So we have to replace this Y. From the reaction rate, which is giving you Y, like you're getting Y here. What's the rate law for the first step? First step is K times concentration of A times concentration of B, which is giving you Y, right? It's giving you Y. Check. So replace this Y by these two. And your rate law will become K. These Ks are different. I'll show you. Let's say this is K1, this is K2. So it is, this is K2. So it is K2 times K1, these two values. Concentration of A, B, B. This can be taken as a new constant. There is another constant here. Rate equals to K times concentration of A, B raised to power. This is the simple version I'm telling you. How they have done it, I'll show you that also. We are good with this? This is the rate law, which is actually combination of these two. Why? Because the rate determining step has Y as the intermediate. And we cannot use Y because Y is not the reactant. So I have to replace Y from the reaction, which is giving me Y. So when I replaced it, I'm getting this rate law. This is called as steady state approximation, how to overcome the intermediates from the rate law. Okay, now let's try to understand in depth. I'm left with less time. I'll give you more practice in the next session. So right now, I'm just giving you 5 minutes are there. So I'll just tell you how it is done. There is a concept which you are going to do in Unit 7, equilibrium. Equilibrium, right? When there is a step which is very fast, like this one, the reaction is going very fast in both the direction, like this. Forward direction, reverse direction. If this is K1, this is K minus 1, like this. Reverse direction like this. Are you getting it, children? Very fast. Going equally in both the direction. Equilibrium, which we are going to do in unit 7. Now the rate for the forward direction means a plus b giving you y is K1 times concentration of the reactant. You're getting it, children? Forward direction. Okay, let me make it more clear. I'm talking about this one, forward direction rate. In terms of these reactants, elementary step is an elementary step, okay? So I can write like that. And rate for the reverse direction, reverse. Now I'm talking about this one, reverse direction, right? In that case, it is K minus 1. Now, what is the reactant for the reverse direction? What is the reactant? Y. Reverse Y. Y is the reactant. In terms of the rate laws are always in terms of the reactants. So that's why Y. Now, it's a reaction which is equilibrium very fast. These two rates are equal. They are equal. Rate of the, that's the concept of your equilibrium. Rate of the forward direction and rate of the reverse direction. RF means forward. I'm going to teach you this again in unit 7. Rate reverse. Reverse. These two are equal. If these two are equal, then I can say K1 concentration of A times concentration of B, this one, is equal to K reverse, this one, concentration of Y. I can rearrange this equation, children. Can I say concentration of Y? This is the approximation they are using, that they are equal. So concentration of Y is K1 over K inverse, right? They have same values, but if one is 100, other one is 1 over 100, like this. Oh, sorry. No, they have different values. They don't have the same values. It depends on the activation energy. I'm sorry, they have different values. So K1, K minus 1 is, I'm rearranging the equation. What else is there? Concentration of A, concentration of B. See this one? Now what's the rate law? Rate law is determined from this step. Rate law is K2. This is K2. Second step, K2. Concentration of Y times concentration of B. I said you cannot take the rate law in terms of Y. Y is the intermediate, is not the reactant of the overall reaction. So what I'm going to do, I'll replace this Y by this expression. So it is K2, K1, K inverse times concentration of A, concentration of B, concentration of B. Now, all these are constant. Rate constant for second step, rate constant for the forward direction, rate constant for the reverse direction. All these are constant. They combine together. All constants combine together to give you a new constant K, concentration of A times concentration of B raised to power 2. That's the rate law which I derived earlier also. So the steady state approximation says never write the rate law in terms of intermediate. Check the step which is giving you intermediate and pick up those reactants. Take that rate law, like here, Y is the intermediate, and I'm getting Y in step 1. So just replace Y by A and B. So when you do it, you get the correct rate law. You need not to show all this mathematics, the one I have shown here, this one. But if you can practice it, I think that will be ideal because AP is changing its faces. So maybe there are questions in which they may ask you to check this, right? So that's the steady state approximation. I have not given you any example today because As I said that I have to go and visit a temple right now, and I'll seek blessings for all of you. Do well in your life, and um, Jagannath Puri is very popular temple, and I'll ask for blessings of the God for all of you. Okay. So see you in the next class. I'll give you extra time in the next class, extra 30 minutes in the next class. So be prepared for it. If you have any questions, you can stay back, but I can give you only 1 minute for that.
Question. Will class go like extra after 7:30, or would
Yeah,
it be
after,
before?
after.
Okay. Okay, also, I'm really sorry about joining late. Actually, I'm out of town, so the time difference and everything really got confusing. Sorry.
No, no, no problem. You can watch the recorded session. This session
Yeah.
is recorded. See you
Yeah,
then.
okay.
Bye bye.
All right, bye.